Now, another concept or one of the applications of this differentiation we have been dealing with since morning is what we call the stationary point. In some cases, they also call it the turning point. It's either they call it the stationary point or they call it what? The turning point. What do we have to understand about this turning point? This will be illustrated with a graph also, the graph of y and x axis. We have a graph like this, and we have a recurrent motion which is sinusoidal in nature. This one represents one of the functions which can be sine or cos. Yes, sine or cos, these are the pattern. Now, when you have a curve on a Cartesian plane like this that repeats itself in a regular pattern, this curve, merely looking at this, we can see the uppermost point here. Yes, the uppermost point of y will be gotten here. This one will be the maximum point here. That's going to be the highest value of y here. This is the highest one. Then when you look at below here, if it does not get to this edge, then at this point, then it's going to experience the minimum point. The least value of y will be experienced here. The highest value of y will be experienced here. This is called the crest on the 12th. That one is another explanation entirely. And these are the x-axis. At this point, where you have the maximum point, there will be a corresponding y. At this point, where you have the minimum point, there will be a corresponding x. Let's call this s1. Let's call this s2. Don't forget that we can also call this y1. Let's call this what? y2. No. But we are not interested in this y1, y2. When you are looking for the stationary point or the turning point are said to be the point at which the maximum point is experienced or the minimum point is experienced. Or more explanation can be given to it by saying that the stationary points are said to be the point at which each of the moving points, there are points are moving through this curve here. Then there will be a point where it's going to appear to be the maximum. The maximum point of y is this. On this maximum point, the differentiation, which is the y, the s that are experienced in this curve, the differentiation at this point, which is the y, the x, is going to be 0 at this maximum point. Also, the same thing is experienced at this minimum point. The derivative, as it moves here, the dy dx on this minimum point is going to be 0 also. So that is why they call it stationary point, because at this point there is no movement for the differentiation. There is no movement for the slope and there is no movement for the gradient. That is why we call it the stationary point. So anytime they are talking of the word stationary point, the stationary point includes the minimum point, the maximum point, and we also have another point that we call the point of inflection. Point of inflection is a point where it is neither minimum or maximum. Point of inflection is a point where it is neither minimum nor maximum. It's a point where it actually gets in between the minimum or maximum. We are not going to dwell more on that, but we are going to focus more on minimum point and maximum point. Now, when we are talking of maximum point, at these 2 points, the y, the ds is going to be 0. So the first thing you have to know is that at the minimum point and the maximum point, or point of inflection, at any stationary point, the reason why they call it stationary point, at any stationary point, the dy, the dx is going to be 0. That's the first understanding of stationary point. Then we can actually be asked to find the type of stationary point we are dealing with. Is either it is minimum or it is maximum or it is point of inflection. How do you get the nature of the stationary point if you are given that type of question? When you are interested in the nature of the stationary point, that is either it is minimum or maximum, the nature of the stationary point, we are interested in it. So what do? You are differentiating the first time, the function for the first time, and you equate it to 0. When you equate it to 0, then you are getting the value of s1 and s2, that is at the point S where the maximum and minimum point occur. Then the nature of the stationary point will be gotten by differentiating the second time, that is looking for the second derivative, which is the 2y the s squared. You have to get the 2y the s squared to find the nature of the stationary point. That is, if it is maximum, then you get it from this second derivative. If it is minimum, you get it from this second derivative, or if it is point of inflation, you get it from this second derivative. Now, how do we now get it? If you differentiated the second time, if your d2y the s squared, and you differentiated the second time, and you get it to be what? Greater than 0, that means it is positive. If it is positive, the graph will be like this. If it is positive, it's going to be like this. This one is coming upward like this. Let's see the graph. It is coming from what? This positive, then it gets to the peak, it's stable, then it's coming here, it's negative here, then it's going up again. This is positive. At the end of the day, when you differentiate the second time and you have a positive sign, at the end of the day, you have a positive sign by imputing the value of your x1 and x2 you have gotten in this first differentiation. We are going to practicalize it with an example. Then when you impute that, you have positive. You have positive, then this point is talking about what? A minimum point. When you have positive, we are talking about a minimum point. A minimum point. But if you differentiate the second time, the 2y the s squared, differentiate the function the second time, and you have it to be less than 0, that is, it is negative. Then we can have the graph represented like this, just as we have above. It is coming from positive, then at the maximum point, which is reached here, then we have negative. Don't forget that this is minimum point. Then we have it coming here, the second derivative is this, then which is negative. If it is negative at this point, then we are talking of what? A maximum point. So a maximum point is coming from positive to negative. Then that produces a what? A maximum point. So if it is neither positive nor negative, then if the 2y the s squared, if it is equal to 0, then we have point of inflation. Point of inflation. Point of inflation. We have point of inflation, and that's what we have for it.